Good day. The topic we are treating today is statistics. This video is a continuation of examples on tabular and graphical representation of data by Monsurat. In this video, we solve more examples on frequency table, pie charts, bar charts, and histogram. And by the end of this lesson, you should be able to solve examples on frequency table, pie charts, bar charts, and histogram. Also, before you proceed to watching this video, you must have been familiar with the topics tabular representation of data and graphical representation of data. Now, we move to the sixth example. We stopped at the fifth example in the previous video. So here we start from the sixth example, which is an example on histogram. We are given an histogram of scores of number of students against scores. So the question says the histogram above represents the number of candidates that sat for mathematics examination in a school. How many candidates scored more than 50 marks? So here we'll go to the histogram. This is the number of students. Number of students is here on the vertical axis and the scores are on the horizontal axis. So we can see that 5 students had 10 marks, 5 students also has 20 marks, 10 students has 30 marks, you can see, because the bar of 30 stops at 10. That is why I said 10 students had 30 marks. So for 40 marks, 20 students have 40 marks. So that is how to read a histogram. We do the same thing for all the scores. For you to know the frequency of the score, that is the number of students that had that particular score, we will look at the height of the bar of that particular score. So the question says, how many students scored more than 50 marks? You know, if you score more than 60 marks, that means if you scored more than 50 marks, that means you are going to have 60 marks, 70, 80, 90, or 100 marks. So those that have scores above 50 marks will be student that has 60, that has either 60, 70, 80, 90, or 100 marks. So for you to get the total number of students that scored more than 50 marks, you sum the frequency of those that scored 60, 70, 80, 90, and 100 marks. So the number of students that scored 60 marks is 40. See, 40. The number of students that scored 70 marks is 25. That's the height of the valve for 70 marks. The number of students that scored 80 marks is 15. 90 is 10 and 100 is 5. So we'll sum this up to know the total number of students that has more than 50 marks. This is a UTME past question, UTME 2009. So the total number of candidates that scored more than 50 marks equals sum of candidates that scored either 60, 70, 80, 90, or 100 marks. As we have determined the frequency, that is the number of students that has 60 marks to be 40 from the histogram, plus, we are talking about sum here. Number of students that had 70 marks is 25, plus number of students that had 80 marks 15, number of students that had 90 marks is 10, and number of students that had 100 marks is 5. So if we should add this together, we are going to have 95 students. So the number of candidates that scored more than 50 marks is 95 candidates. So that solves the question. Now we move to question 7. In question 7, here we can see that we're talking about a pie chart. So this is a right angle which is equals to 90 degrees. So now let's read the question. The question says the grade of 36 students in a class test are shown in the pie chart above. How many students have excellence? The total number of students in that particular class that took part in the test is 36. So we are to obtain the number of students that has excellence, but the sectoral angle of excellence is also not given, but we have the sectoral angle of all other grades, which is pass, credit, and very good. So 120 degree is sectoral angle for pass, 80 degree is sectoral angle for credit, and 90 degree, this symbolizes 90 degree, is sectoral angle for very good. So to obtain the sectoral angle for excellence, we know the total angle in a circle is 360 degree. So we sum these three grades and deduct it from 360 degree to know the sectoral angle of excellence. After that, we now obtain the total number of students that has excellence. So now let's move to solution. This is also a UTME past question, UTME 2012. So we first obtain the sectoral angle of excellence as I've explained. Sum of sectoral angle of all the grades, which is the sum of angle in a circle, equals 360 degree. So this implies that sectoral angle of excellence plus that of pass, very good, plus that of pass, very good, and credit, which is given here. This is for pass, this is for very good, and this is excellent. Everything equals 360 degree. So we will make sectoral angle of excellence the set of formula, which will give sectoral angle of excellence plus 290 degree equals 360 degree. So to get the value for this, we take this to the other side, and 360 degree minus 290 degree will give 70 degree. Therefore, the sectoral angle of excellence is 70 degree. So from the question, the total number of students that took the test is 36. So now we can use this information. Since we have the sectoral angle for excellence, we have the total number of students, so we can obtain the number of students that has excellence using the formula for obtaining sectoral angle of excellence. So that is the number of students that has excellence divided by the total number of students times 360 degree will be equal to sectoral angle of excellence. That is how to find sectoral angle. So number of students with excellence is what we have to obtain. We know the total number of students will be 36 multiplied by 360 degree, and as we've obtained now, the sectoral angle of excellence is 70 degree. So we make number of students with excellence the set of formula. We multiply 36 by 70 degree and divide by 360 degree. So if we should do that, we have 7 students. So now we've obtained that the number of students that has excellence is 7. Question. This question is also on pie chart. It is also a UTME past question, UTME 2013. We are given a pie chart with subjects mathematics, economics, physics, chemistry, and English language, and their sectoral angle is in terms of x. So for us to know the sectoral angle of each subject, we must first obtain the value of x and substitute it back into the sectoral angle to know the sectoral angle of each subject. So the question says, the pie chart above shows the statistical distribution of 80 students. So from the question, we know the total number of students is 80 in 5 subjects in an examination. So we have to calculate how many students offer mathematics. So it's just like the previous question. The first step is to obtain the value of x. Then we substitute the value of x into the sectoral angle of each of the subjects to obtain their original sectoral angle, which will not be in terms of x. Then after that, we now use the formula for obtaining sectoral angle to calculate the total number of students that offers mathematics. So now let's move to solution. From the question, the total number of students is given as 80. So we first obtain the value of x. to know the real sectorial angle of the subject. So we know that the sum of all the sectorial angles of the 5 subjects will be equal to 360 degrees, which is the sum of angles in the circle. So we sum the angles together. So this is the sum. So now we collect the like terms. So we collect those in terms of x and those that have whole numbers. So this is 6x degree plus 5x degree will give 11x degree plus 16x degree will give 27x degree plus 5x will give 32x degree plus 4x degree will give 36x degree. So we add the numbers together to 12 minus 24 will give minus 12. Minus 12 plus 12 will give 0. So we are left with 36x degree plus 0 equals 360 degree, which is same thing as writing 36x degree equals 360 degree. So now we make x the sort of formula. We divide through by 36 degree and we have x to be equals 10 degree. So now we substitute the value of x into the sectorial angle of each of the subjects. For English, the sectorial angle given in the pie chart is 6x plus 12. So since x is 10, we have 6 multiplied by 10 plus 12, which is 72 degree. So the original sectorial angle for English is 72 degree. So we do the same thing for chemistry. We got 52 degree because we have 4 multiplied by 10, 40 plus 12 will give 52 degree. So for mathematics is 5x. So 5 multiplied by 10 will give 50 degree. Economics 16x minus 24. So that is 160 minus 24 degree, 136 degree. And the last subject, physics, which is also 5x degree equals 5 multiplied by 10 degree, which is 50 degree. So we should sum the sectorial angle obtained when we substitute the value of x into the sectorial angle of the subject, which is in terms of x. If we should add it together, we must get 360 degree. So now let's check. 50 degree plus 136 degree will give 186 degree plus 50 degree will give 236 degree. 236 degree plus 52 will give 236 degree plus 52 will give 288, and 288 plus 72 will give 360 degree. So that is correct. We've obtained the original sectorial angle of the subject. So now we will now answer the question that says how many students offers mathematics. So here, like the previous questions, since we know the total number of students and we know the sectorial angle of mathematics, we can use the formula for obtaining sectorial angle to obtain the number of students that offers mathematics. So now we all know that the formula for obtaining sectorial angle equals number of students that offers math over total number of students multiplied by 360 degree will be equal to sectorial angle of mathematics. So the number of students that offers math is what we are to obtain, and total number of students as given in the question is 80 multiplied by 360 degree. Then we all know that the sectorial angle of mathematics, which we just obtained, is 50 degree. So now we make this set of formula, which is multiplying 50 degree by 80 divided by 360 degree. So we should evaluate this. We have 11.11 students. You know, a human being cannot be 0.11, so we can approximate it to 12 students. So 12 students offers mathematics. That solves the question. Therefore, the total number of students that offers mathematics is 12 students. So that's the solution of that question. So we move to the next question, which is question 9. This question is on Instagram. This question shows the mark distribution in a class test. So we have to find the total number of students in that particular class. This is also a UTME past question, UTME 1984. So you know, to get the number of students that are 0 to 9, we look at the height of the bar for 0 to 9, the number of students. So for 0 to 9, 4 students add marks between 0 and 9. So between 10 and 19, 6 students. So we are going to add the height of this bar to know the total number of students that took that class test. So now, this is the question. The bar chart above shows the mark distribution in the class test. Find the number of students in the class, ETM in 1984. So score booster solution. The total number of students in the class equals to the sum of the height of the bars, which I just explained. So we sum this 4 plus those that had marks between 10 and 19 inclusive to 20 to 29. We had it to 30 to 39, also to 40 to 49 and 50 to 59. So for 0 to 9, we said it's 4, which is the height of the bar. 10 to 19, 6, 20 to 29, 8, 30 to 39. We can see that this is like dividing the space between 8 and 10 into 2. And the number between 8 and 10 is 9. So for 30 to 39, we can see that 9, if you are looking at this, is 9. 40 to 49 is dividing the space between 4 and 6, which will give 5. And 50 to 59 is what? 2. So we add this together. 4 plus 6, 10. 10 plus 8, 18. 18 plus 9, 27. 27 plus 5, 32. 32 plus 2 will give 34. So the total number of students in the class test is 34. So it's as simple as that. If you want to know the total number of students in the bar chart, you just add the height of each bar, you sum them together to know the total number of students or total number of events that occurs on that particular histogram. So now we move to the 10th question. This does not have anything to do with diagram, so we just read the question. In a class of 120 degrees, so from the question we know that there are 120 students. In a class of 120 students, we know that there are 120 students in the class. They said 18 of them scored A grade in mathematics. 18 of 120 students scored A grade. If the section representing the A grade students on a pie chart has Z degree, so this Z degree is representing the sectoral angle of A grade. 120 students took a mathematics test. 18 of them had A grade, and when we find the sectoral angle of A grade, they represent it as Z degree here. So what is Z? So this is just like telling us that we should obtain the sectoral angle of A grade. That is what the question is trying to say. They are trying to tell us that the sectoral angle of A grade is represented as Z here. Then we'll find the value of Z. So if we want to find the value of Z, we find the sectoral angle of student that has A grade. And we are already given the number of students that has A grade to be 18, the total number of students to be 120. So we now have all parameters to obtain the sectoral angle of A grade. So now we move to score booster solution. From the question, the total number of students in the class is 120. The number of students that scored A grade from the question is 18. So now, from the question, the sectoral angle of student that scored grade A is given as Z degree. So we know that Z degree is the sectoral angle, and the formula for sectoral angle is number of students that scored A grade plus total number of students times 360 degree. And from the question, the number of students that scored A grade is 18. The total number of students is 120 multiplied by 360 degree. So we should evaluate this. We have 54 degree. So since we have to find the value of Z alone, not Z degree, so the value of Z equals 54. We are talking about Z alone, not Z degree. So therefore, Z equals 54. And that solves the question. So we move to the 11th question. In the 11th question, we were given a table It's just like a frequency table. We have the number of goals between 0, we have number of goals from 0 to 6, and the frequency of the goal, that is the number of times they have that goal. They have 0 goals 4 times, one goal 3 times, 2 goals 15 times, 3 goals 16 times, 4 goals once. They do not have 5 goals at all, and 6 goals once. So let's check the question. The question says, from this table, what is the total number of goals scored by all the teams? So this is also a UTME past question, UTME 1987. So we have to obtain the total number of goals scored in this table. So let's do it in a practical way. These are the number of goals. For 0 goal is scored 4 times. So we have to add it 4 times, which is 0 plus 0 plus 0 plus 0, which will give 0. One goal, they had 1 goal thrice, which is like having 1 goal 3 times. So for here we have 0. This will be 1 plus 1 plus 1, which is 3. 3 plus 0 will give 3. 2 goes 15 times, so we should have 2 15 times. We have 30. So 30 plus 3 will give 33. So we'll do the same for all the goals. But this is going to take a long time. If you want to have a simpler form of this, to know the total number of goals, we have the sum of each number of goals multiplied by its frequency. 0 multiplied by 4, 0, which is what we have the other time. 1 multiplied by 3 is 3, because they have 1 goal thrice. So that means they have 3 goals. If you play one match, you scored 1. The second match you scored 1. The third match you scored 1. You have 3 goals like that. So for 2 goals, the score is 15 times. So they're saying that 2 multiplied by 15, because if you have 2 to itself 15 times, you have 30. So it's the same thing as saying 2 multiplied by 15 to get 30. Then so for 3 goals, if you should have 3 16 times, if you have 3 to itself 16 times, you have 48. 3 multiplied by 16 is 48. So 4 goals, they had it just once. They did not have 5 goals at all, which is like 0. 5 multiplied by 0 will give 0. They don't have it at all. And they have 6 goals once. So this is just like multiplying the number of goals by its frequency and adding them together. So for us to know the total number of goals, it will be equal to sum of each number of goals multiplied by its frequency. So the first one is 0 goals, they had it 4 times, is 0 multiplied by 4, plus 1 goal thrice, 1 multiplied by 3, plus 2 goals 15 times, 2 multiplied by 15, plus 3 goals 16 times, 3 multiplied by 16, plus 4 goals 1, 4 multiplied by 1, plus 5, they did not have 5 goals at all. So that's 5 goals multiplied by 0, plus 6 goals once, which is 6 multiplied by 1. So if we should evaluate this is 0 plus 3, which is 3. 3 plus 30 is 33. The 3 plus 48 is 81. 81 plus 4 is 85. 85 plus 0 is 85. And 85 plus 6 will give 91. So the total number of goals scored by all the teams is 91 goals. So we can see the difference of this particular table from the ones we've solved earlier. So here we have to calculate the number of goals, the total number of goals scored by the team. So now we move to the next question, which is question 12. Question 12 is on bar charts. The bar chart shows the distribution of mark in a test. So assuming 5 is the pass mark, that is, if you have 5, it means you have passed. What percentage of students failed the test? This is also a UTME pass question. It's year 2012. So we are told that if you have 5 and above, you've passed. That means if you have anything below 5, you failed the test. So we have to look for the percentage of students that failed. So if you are given this kind of a question, the first thing you do is look for the total number of students that failed before you can obtain the percentage of students that failed that particular test. So, we already told from the question that 5 is the pass mark. So if you have 5 and above, you pass. So for you to know the number of students that failed, they will have the marks 4, 3, 2, 1, or 0. So those are the marks the student that failed we have. And we know that number of students that have 0 mark is 2. Number of students that have 1 mark is 3. Look at the height of the bars. The number of students that have 2 marks is 4. The number of students that have 3 marks is 6. And the number of students that have 4 marks is 5. So sum all this together. 2 plus 3, 5. 5 plus 4, 9. 9 plus 6. 9 plus 6, 15, and 15 plus 5 will give 20. But from this question, we are not given the total number of students. So for us to know the total number of students, we had the height of each of those bars for all the marks. So which is 2 plus 3 plus 4 plus 6 plus 5 plus 4 plus 6 plus 5 plus 1 plus 3 plus 1. So, and if that is evaluated, we have 40 students. So the total number of students in this that did this class test is 40. So now let's move to the solution. So to obtain the total number of students, as I've explained, it will be sum of height of each bar, which is what we have here. So if you sum this together, we have 40 students. I've explained that earlier. So the total number of students that took part in the test is 40. So as I've explained, 5 is the pass mark. That is, if you have 5 and above, you pass. So to know the total number of students that failed the test, it will be the sum of students that have marks below 5. That is, those that scored 0, 1, 2, 3, and 4 marks. So total number of students that failed will now be sum of height of the bars of these scores, which is these 5 scores: 0, 1, 2, 3, and 4. So 2 people add 0 mark, plus 3 people add 1 mark, 4 people add 2 marks, 5 students add 3 marks, and 6 students add 4 marks. So we sum this together: 2 plus 3, 5, 5 plus 4, 9, 9 plus 5, 14, and 14 plus 6 will give 20. So the total number of students that failed that test is 20. So now we know the overall total number of students and total number of students that failed. So now we now have all the parameters to obtain the percentage of students that failed the test. And you know how to obtain percentage. It will be the number of students that failed divided by total number of students multiplied by 100, since we are dealing with percentage. So this is it: number of students that failed over total number of students multiplied by 100. So you know the number of students that failed to be 20. Total number of students 40 multiplied by 100. So we should evaluate this. We have 50%. So the percentage of students that failed the test is 50%. So that solves the question. Now we move to the last question, question 13. This question is also on pie chart. So this question also talks about the grades of students in a particular course. So what percentage of the students obtain a C4 grade. So this is a C4 grade. The sectorial angle for C4 grade is for 3.2, but we don't know the total number of students, neither do we know the number of students that had C4 grade. But we have to obtain the percentage of students that obtained a C4 grade. So now move to solution. The first thing you will obtain is the number of students that have grade C4, and this will be obtained using the formula for sectorial angle, since it is only the sectorial angle of C4 we know, which is for 3.2 degrees. And the formula for sectorial angle will be number of students with grade C4 over total number of students multiplied by 360 degrees will be equal to sectorial angle of C4. And we don't know the number of students with grade C4, and that is what we first want to obtain here. We don't know the total number of students times 360 degrees, but we know the sectorial angle of grade C4 to be for 3.2 degrees. So since the first thing we want to do is to obtain the total number of students with grade C4, we make this the set of formula, and that will be given as number of students with grade C4 will be equal to total number of students multiplied by 3.2 degrees, which is sectorial angle of grade C4, divided by 360 degrees. So this is the total number of students. This is what we assume to be the total number of students that has grade C4. So now we now know the number of students that has grade C4 in terms of the total number of students. So now we obtain the percentage of the number of students with grade C4. I know to obtain the percentage, it will be the number of students with grade C4 over total number of students multiplied by 100. So this is it. So number of students with grade C4, this is the number of students with grade C4, which is for 3.2 degrees times total number of students over 360 degrees, divided by this total number of students here multiplied by 100, since we have to obtain the percentage of students with grade C4. So now if this is evaluated, we can have for 3.2 degrees times total number of students over 360 degrees divided by total number of students, and if it should change to multiplication, we have 1 over total number of students. So total number of students will cancel total number of students. We will be left with for 3.2 degrees multiplied by 100 over 360 degrees. So if you should evaluate this very well, you have that result for 3.2 degrees multiplied by 100 over 360 degrees, and if this is evaluated, we have 12%. So therefore, the percentage of students that has grade C4 is 12%. So you can obtain the percentage of a particular section of a pie chart even without knowing the number of students that are that section or the total number of students. So that is what we did here. So that solves the question, and that ends the example. So now we have exercises for you to solve to see if you understood what we have been explaining. We have 7 examples in all, and they are all UTME past questions. So that is all on the tabular and graphical representation of data. Next video will be on statistics, that is measure of location with sample questions and solution. Please subscribe to our YouTube channel, like and share our video. Thank you.